Quantitative literacy. These are the notes for 12.3, measures of dispersion. First thing, this Simpson's paradox thing, if we were in class, we would have done this, but do not worry about it. So we're going to skip right over all that. A measure of dispersion is basically saying how spread out are the data. The simplest way, if you will, to measure dispersion is the range, which is just the biggest number minus the smallest number. The range, though, is not a great way of measuring dispersion because if you have one really big value or one really small value compared to everything else, it's going to change your range a whole bunch. So that idea that outliers mess up stuff really happens in the range. What's more important and the main drive of these notes is the standard deviation. So this measures how spread out the data values are. It gives a score to it. Deviation, deviating from. And the question is, what are they deviating from? It's deviations from the mean. And a reminder, the mean is X bar. So basically it measures out how far away each value is from the mean. So this first one is going to basically kind of step us through the standard deviation and kind of explain why we do what we do, because there's a lot of weird calculations that happen. So for the first one, we've got 5 data values, 32, 41, 47, 53, 57. If we add those up and divide by 5, so if I added these all together and then divided by 5, I'd have the mean. So if you add them all up, it's 230. And we're going to divide by 5. And we get 46. Okay, so that's the mean. Now I want to figure out how much each value deviates from the mean, how far away it is. And what I'm going to do is I'm going to take the data value, which I'll call my X value, and I'm going to do X minus the mean. So X minus X bar. So the first one, and this would just be in your calculator off to the side. The first one would be 32 minus 46. That's negative 14. Next one would be 41 minus 46, negative 5. And just keep doing that. 47 minus 46, 1. 53 minus 46, 7. 57 minus 46, 11. Okay, so those green numbers there are the deviations from the mean, how far each value is from the mean. Okay, so a logical thing, it doesn't actually work, but a logical thing would be, all right, let's take each one of those deviations and average them. That would give me kind of an idea of, on average, how far away is stuff from the middle. Because that's what my goal is here, is to give me an average idea of how far away everything is. But here's the issue. If I take those deviations, negative 14 plus negative 5 plus 1 plus 7 plus 11, and I divide those by 5, an interesting thing happens. The numerator is 0. 0 divided by anything besides a 0 is 0. This is not a coincidence that I got 0. This would always happen if I tried to do this. So if I tried to simply average how far away everybody is from the mean, it's always going to be 0 if I do this. And by definition, that makes sense because the mean is right in the middle. So you've got some stuff smaller, some stuff above. They'll cancel one another out. So this doesn't work. So mathematicians, statisticians, had to figure out some other way because they realized we were always getting 0 when we added up all those deviations. What we do in math, a way to get around this is, well, it's these negatives that are messing us up, the negative 14 and the negative 5. I can get rid of negatives by squaring them, because when I square a negative, I get a positive. So I'm going to square each one of these numbers. So negative 14 squared is 196. Negative 5 squared is 25. 1 squared is 1. 7 squared is 49. 11 squared is 121. Now I've taken care of that issue of I had some negative, some positive. Now I'm going to average these numbers together, kinda. So I'm going to add these up, but now instead of dividing by 5, I'm going to divide by n minus 1. N is how many values I had. I have 5 values. Now, why am I subtracting 1 from that? So let's backtrack first. On letter B, I said, hey, let's divide by 5. That's how you usually do an average, divide by how many you have. On this one, I'm going to instead divide by 4, 1 less than it. Now, why do I do that? That's a story for a high-level statistics course. We're not going to worry about it in here. Just take my word for it. It is important, but just go with it. I'm not going to explain why. So we're going to divide by 4. This is kind of finding the average of these numbers. If you do this, you'll get 392 over 4, which is 98. So I kind of found an average of the square of each one of those deviations. All of these were squares. I squared everything out. But, okay, I squared them. Let's take the square root now so that we get rid of that idea of squaring it, because 98's a big old number. So in the end, I square root that 98, and that gives me about 9.9. That is the standard deviation. So what is this saying? In this data set, 32, 41, 47, 53, 57, the, if you will, average deviation from the mean, the average deviation from 46 is about 9.9-ish. Now, this was a pretty bizarre process. Again, if we were in a statistics theory class, we would dive a lot more into it, of why it works. But the steps are summarized here. In this table. So what is this saying? If we look at this from inside out, well, actually, let me do this. This will be a little easier, I think. Open up another window here. Okay, so the first thing we did was we figured out the mean. So that's X bar. We then found the deviations from the mean. So step 2, step 1 we did. Step 2 was to find the deviations from the mean. That was taking each value and subtracting off the mean from it. That was step 2. Some of those were negative, some of those were positive. To clear that, we just squared all of those numbers. That was step 3. We then added all of those together. The symbol sigma in math, remember, means sum. So that kind of looks like an E thing, it's sigma. So that was add all those up. That was step 4. We then kind of found the average by dividing that number by 1 less than how many data values I had. That was step 5. And lastly, we said, oh, we squared stuff. We have to undo squaring by taking the square root. That was step 6. So the big scary formula here really is all of that in pieces. So let's try this on example 1 now. So I'm going to go through all these steps. Now on this example, because your homework does this too, it also asks for the range. So this is just off to the side. The range is just the biggest number minus the smallest number. So the range, the biggest number here is 20. The smallest number is 6. So 20 minus 6, 14 is your range. But that has nothing to do with standard deviation. And again, it's not a great measure of how spread out stuff is. It's somewhat useful, but it's not all that helpful for us. Okay, the standard deviation is what matters a lot more. So standard deviation, first step is to find the mean. So X bar. So that's add up all the values. And if you add those up, you should get 84. And then divide by how many you have, which was 7. Fortunately, that comes out nice. That comes out to 12. Okay, so I got my mean. So that was step 1. Step 2, find the deviations from the mean. So that's subtract each value from the mean. So that's going to be, let's see. I'm gonna kind of do this in just a little list here. So my values are 6, 12, 10, 8, 9, 20, 19. Okay. I'm going to subtract off the mean from each one of those. This will give me my deviation. So I've got, if I do all that, I've got -6, 0. That's okay. That can happen. -2, -4, -3, 8, 7. Okay, that was step 2. Oops. So going back over here. Let's do this. There we go. There we go. That was step 2. Step 3, square each one of these numbers, okay? So the next thing is to square each one of these. Okay, that's going to give me 36. 0 squared is 0. 4. 16. 9. Again, be careful on all this. Whenever you square, you get a positive. So that was the whole point of squaring each one, is that they all became positive. Okay, so that was step 3. Step 4, sum all of these. So now I'm going to add up all of these numbers. And if you add up all of those, you should get 178. Okay, so that was step 4. Step 5, divide that sum by n minus 1. There were 7 values. So I'm going to take that number and divide by, oops, not 4. I don't know where that number came from, sorry. I'm going to divide by 6. That is about 29.6 repeating, and I would just have that in your calculator. Don't round it, just call it 29.6. And the very last step is to take the square root of that number. So in your calculator, square root that number. And we're going to take it to 2 decimal places. You should get the standard deviation, which is just a lowercase s. The standard deviation is about 5.45. So obviously it is a process to find the standard deviation. In real world data, we let a computer do it, because if I had 100 different values, I have 7 here. If I had like 100 or 200 or 1,000 numbers, this would take forever to do by hand. So we'd let a computer do it, but we're going to do it with small sets by hand. We'll do a second video for the last problem, because the last problem we have to do a couple things too.